Hi class. In this lecture we continue in chapter 1 talking about linear equations and linear functions by moving into section 1.2, graphing linear equations. Now I'm going to talk about how you would graph them by hand, and then also I'm going to show you how to use your graphing calculator. So if you have your graphing calculator, have that handy while you're watching this video, um, and be sure to pause it and rewind as you need to when you watch me show you how to graph with your graphing calculator. Okay, so first off, when graphing, you need what's called ordered pairs. Okay, so for an ordered pair, and it looks in parentheses and then A and B. Now I'm going to write it as A and B here just to define it, but what you're used to seeing is probably the X comma Y. All right, so don't get confused with the A, B for now. We'll still use X and Y later. But as we get further on into the class, we'll stop calling things X and Y. So I just want to define it with A and B here. So for an ordered pair, parentheses A comma B, we write the value of the explanatory variable first, so in the left position, so the explanatory variable, and then the value of the response variable in the second position, the right, okay? These numbers A and B are what are called the coordinates, right, of the point. All right, so let's talk about solution satisfy and solution set of an equation in two variables. So an ordered pair is actually a solution of an equation in X and Y if the equation becomes a true statement when A is substituted in for X and B is substituted in for Y. All right, so what we then say is when we plug those numbers in for the X and Y in our equations, all right, we say that A comma B satisfies the equation. All right, so the solution set, now in mathematics, a set is a collection of things. So a solution set is of an equation is the set or collection of literally all the solutions of the equation. All right, so a solution set can have only one possible solution, or it could contain an infinite number of solutions to it. All right, so let me give you an example. All right, suppose I have this equation. All right, y is equal to negative x plus 1. And what I want to do is I want to find 5 different solutions to this equation. And then once I have those solutions, I want to plot them on a graph. Okay, so to find solutions, we are free to choose any values we'd like to substitute in for x, literally any numbers, okay? You could go with negative 100 all the way to a billion, whatever, okay? But it's always a good idea to pick integers. So integers are like negative 3, negative 2, 1, 0, 1, 2, 3. Okay, so pick integers close to or equal to 0. So the solutions that you get are super easy to plot. All right, so let me show you, for example, when we substitute in the numbers 0, 1, and 2 for x. Okay, so when I plug in, remember, I'm free to choose any values. When I pick 0 for x and plug it in, all right, so I'm replacing the x with 0. I get negative 2 times 0 plus 1 gives me 0 plus 1 equals 1. All right, so what this is saying is the solution that I just found, all right, to this equation right here, it says that, look, when x is equal to 0, y is equal to 1. Now that's one solution to this equation. But now what happens if I said, well, hold on a second, x is equal to 1, okay? Well, negative 2 times 1 plus 1 gets me negative 2 plus 1, which is negative 1. So I have a different solution to this equation, all right? When I plug in 1 for this equation, it turns out that y becomes equal to negative 1. So another solution to this equation is the point, or the ordered pair, well, when x is equal to 1, comma, y was equal to negative 1. And you can follow along when you plug in 2 into this. When x is equal to 2, you see that y is equal to negative 3. These are 3 different ordered pairs, okay, 3 different ordered pairs, yet they're all a solution to this equation. So I'm going to go on and do this same thing. Let's say if I pick some negative numbers like negative 2 and negative 1 for x. So when I plug negative 2 in here, don't forget that a negative times a negative becomes a positive. So negative 2 times negative 2 becomes 4. And then I add 1, I get 5. So another solution, all right, another ordered pair to this is negative 2 comma 5. And you can follow the algebra here for negative 1. Okay, negative negative becomes a positive. This is 2 plus 1 gets me 3. So one new ordered pair or solution is -2, 5. Another one is -1, 3. All right, so when we organize our findings, what I want to do is I want to put them in a table just so it's easy to consume or easy to look at. So here what I'm doing is I'm listing all my x values that I picked. I start with the lowest number all the way to the highest. And over here I put their corresponding solutions, or the values I got for y. Like for example, when I plugged in -2 for x, I got 5 for y. -1 for x, I got 3 for y. 0 for x, I got 1 for y. 1 for x, I got -1 for y. 2 for x, and then I got -3 for y. So that's just a table that just very simply summarizes my values for me. Okay, so now what I want to do is I want to plot the solutions. All right, now what I have here, when you look at this, it looks like kind of a jumbled mess, but it has all the solutions plotted. And I want to walk you through how I got them. So I start with my axes, excuse me. I have my x-axis, and each one of these tick marks on it represents a value of 1. So here's 1 for x, 2, 3, 4, and 5. This middle point here is 0. And then to the left of that, I got -1, -2, -3, -4, -5. The y-axis, I got 1, 2, 3, 4, 5. And then also negative y values, -1, -2, -3, -4, -5. All right, so how I would plot this first point, -2, 5. Well, it's telling me x is -2, so I go over to -2, and then it's telling me y is 5. So then once I'm at -2 for x, I go 1, 2, 3, 4, 5. Boom, right there. That blue dot right here is the plotting of -2, 5. -1, 3. Well, x, I go over -1, and then the y tells me to go up 1, 2, 3, right there. How do I plot 0? Well, I'm at the x-axis. It's saying x is equal to 0, so I don't move. And then I go up 1. I got it. Plot the point 1, -1. We'll start at the origin. I go over to 1, then down to -1. Plotting 2, 3. I go over to find x when x is equal to 2. And then I go down to -3 for y. All right. So if you haven't seen this for a while, it just how I got like 1, -1. I started at the origin. I go over 1 for x, and then down -1. And I did that all for the different numbers. That was it. All right, so a graph now. All right, once we have these points plotted, the graph of an equation in two variables is the set of points that corresponds to all solutions of the equation. Now, what's interesting, if I go back here, look at the points I plotted, do you notice that the points like kind of follow this straight line pattern? What it means is there's more than 5 solutions. Like as I go left to right, it looks like the pattern is it's going down. So there should be more points that go down this way. And similarly on the opposite side, there should be more points going up this way. So what this graph does is it attempts to show that pattern or all these solutions that there could be to this equation. So let me go back for a second. Believe it or not, this equation right here, this y is equal to -2x plus 1, actually has an infinite number of points, all right? An infinite number of ordered pairs that will solve it. Infinite, okay? So we use a graph to show those infinite solutions. All right. So what do I mean by these graphs? If an equation can be put into the form y is equal to what we call mx plus b, this is called the slope-intercept form of an equation. So if you want to write that down or note that slope-intercept, we'll come back to it, all right, the slope-intercept form in later sections, right? But for now, all we're saying here is where m and b are constants. Okay, so they're just, m and b are just numbers. Let me go back here. This is actually in the y is equal to m. Here is just -2. X plus b is just 1. Okay, so the m and the b are just constants. They're just numbers. Then the graph of this equation, it's just a line. That's literally all it is. It's just a line. All right, so suppose I ask you to graph a linear equation. So I want you to sketch the graph of this. 4y minus 8x plus 12 is equal to 0. Well, the first thing you have to do is you look at this, you're like, oh my gosh, this does not look like that y is equal to mx plus b. All right, it's got all these numbers in front of it. They're all on one side, they're all on the left side of the equation. So the first thing you have to do is you have to take this equation and you want to solve it for y. You literally just want to get the y by itself. Okay. So the first thing you're going to do, I notice I have a minus 8x. So to get rid of it, I'm going to add 8x to each side. Whatever I do to one side, I'm going to do the other. So minus 8x plus 8x is gone. 0 plus 8x, excuse me, is just 8x. So I have 4y plus 12 is equal to 8x. Now I got to take this 12 and get rid of it. So to get rid of plus 12, I subtract 12. So whatever I do to one side, I do to the other. These are not like terms, so I can't do anything with them. So the 12 and negative 12 just cancel, like so. Now I've got this 4 in front of the y. So what I do is I divide everything by 4 to get rid of it. And if you notice, 8 divided by 4 is 2. 12 divided by 4 is 3. 4 divided by 4, they just cancel each other out. And you're just left with y is equal to 2x minus 3. All right. Now what I want to do is I want to graph this. Y is equal to 2x minus 3. All right, since the equation y is equal to 2x minus 3 is in the form of that y is equal to mx plus b, all right, what we know is the graph of this equation is some straight line. It's a linear line. All right, so what we're going to do is we're going to calculate 3 solutions for this. All right, and what you want to do, remember when you want to find these solutions, those are those ordered pairs. You get to pick any values you want. All right, so go easy on yourself. All right, I'm going to pick the x values 0, 1, and 2 because they're super easy as values of x. And what I'm going to do is I'm going to show them in a table. All right, so set up a table to solve here. I put my x here, and then under it, I'm going to put the values I'm picking, 0, 1, and 2. And then literally, I'm just going to say, all right, well, if I plug 0 in for x, what is y? Well, 2 times 0 minus 3, well, that's 0 minus 3 is minus 3. 2 times 1 is 2, minus 1 is minus 1. Or excuse me, minus 3 is minus 1. Sorry about that. And 2 times 2 is 4. 4 minus 3 is 1. Right, so I just have 3 ordered pairs. One is 0, negative 3. The other one is 1, negative 1. The other one is 2, 1. All right, so then when I go to plot these, right, remember, one point is 0, negative 3. So my x value is 0, so I don't move from the origin, and then I go down negative 3. My next point is 1 comma negative 1, so I go over 1 to x, down 1 to negative 1. My next point is 2 comma 1, so I go over 1, 2, and then up 1 here for the y value. Once I have my 3 points plotted, the way I sketch the line through them is I just literally draw this line that connects or goes through all 3 points, make it as straight as possible. And then I put these little arrows on the 2 ends of the line. What this tells me is that this pattern goes up forever here and down forever this way. And that's it. That's how you sketch a line, just like that. All right, I want to show you how to use your graphing calculator to do this. Okay, so we can use a graphing calculator to view the graph as like a partial check. It'll never look like as good as doing it by hand that we just did. This check will not reveal whether we isolated y correctly, so just be careful of that because we're just entering y is equal to 2x minus 3 rather than the original equation. So your check only works, all right, if you correctly simplify their equation. All right, so let me show you how to do that. So you're going to take your graphing calculator, right? You're going to turn it on. And whenever you want to graph something with your graphing calculator, you're going to hit this y equals button right here on your graphing calculator. So y equals. You're going to notice it's going to say y1 is equal to. Well, you want to plug in this equation, 2x minus 3. So you're going to type 2. Then you're going to notice this button that looks like this. It's like x, comma, then something that looks like a T, then 2 Greek letters here, okay? This button right here represents your variable button. So you're just going to click that. Notice it's going to put an x in there. And then I want to subtract 3. Right, after you got the equation in, just hit enter. And for now, I'll talk about like the window, the zoom, and the trace stuff later. All right, just hit your graph button right here. And you can see that it plots the line for you, just like this. All right. So going back or looking at our equation here, you can see that they're very much the same line. Okay. Um, it's just that, this doesn't do as great a job as showing like exactly where the points are. All right. We'll talk about some of the other options like the zoom and the trace later on when I get to it. But for now, just pay attention to like, yes, my graphing calculator helped me show the line. All right, we're going to get a chance to use our graphing calculator a lot more in the coming weeks and stuff. So keep it handy and repractice what I just showed you, the y equals, to plug it in and then graph to see it. Okay, now I want to talk about the intercepts of a graph of an equation. All right, so for an equation containing variables x and y, all right, we want to find what are called the x-intercept and the y-intercept. So to find the x-coordinate of each x-intercept, so remember the x-intercept is where it crosses the x-axis. What we do is we substitute 0 in for y and solve for x. So to find the y-coordinate of the y-intercept, we substitute x in and solve for y. So if this is how I remember. If I want to find the x-intercept, I set y equal to 0. If I want to find the y-intercept, I set x equal to 0. So you set the other variable. All right, so let's just look at this equation right here. So I want to find the x-intercept, all right, or where it crosses the x-axis of y is equal to negative 2x plus 4. All right, well, I know or I remember that to do this, I take my equation and I set y equal to 0. I change the y value to 0. So what I have to do now is I have to solve this equation for x. So the first thing I'm going to do is I'm going to add 2x to each side to get rid of the negative 2x. So then I'm left with this. Then the next thing I'm going to do is I'm going to divide both sides by 2. And the value of the x-intercept is x is equal to negative 2. So now the x-intercept is actually a point on the graph. So the x-intercept is the point. Well, I found that x is equal to 2, so x goes first, comma, what was y? Y was 0. All right, we pick the y value. Now when we want to find the y-intercept, all right, remember what I said, I want to find the y-intercept, I set the other variable equal to 0. So I'm going to plug I'm going to plug 0 in for x here. Well, negative 2 times 0 is 0. 0 plus 4 is just 4. So the y-intercept, well, what was x? It's a point, so x was 0, because that's what I picked, and the value of y then was 4. All right, so now I want to sketch the graph of this. So actually, you only need 2 points on a straight line to sketch a graph, but I'll find a third one. So I'm going to list an additional point here. So 0, 4, all right, this is the y-intercept. 2, 0, that's the x-intercept. So 0, I'm just going to pick 1. When I plug 1 into this, negative 2 times 1 is negative 2, plus 4 gets me 2. So that's my third point. So now that I've got 3 points, what I'm going to do is sketch them. So I've got the point 0, 4 up here, the point 1, 2 here, and the point 2, 0 here. And then I'm literally just going to sketch the line right through them like so. All right, so what's cool about your graphing calculator is you can use a graphing calculator to verify your graph. So you can use 0, right, to verify the x-intercept, and then trace to verify the y-intercept. Let me show you how to do that with your graphing calculator. So when you have your graphing calculator, right, remember what I plugged in here was the equation y is equal to negative 2x plus 4, or that was the equation we were working with. So I'm going to hit y equals again. I already have something in here, so I'm going to clear it out. You have to listen to me on this. This is really important. When I want to plug in negative 2x, you don't want to use this button here because that's subtraction. So this is the negative button. So you're going to go negative 2, and then your x, and then plus 4. Hit enter. Now when I hit my graph button, notice how this graph is what I have right here. Okay? It looks a little different because it's not as zoomed in as close. But watch what happens when I hit this trace button. Notice up here, it traces, it puts you right at the y-intercept. Well, the y-intercept was 0, x is equal to 0, comma 4. And then what you could do is you could press this button until you get close to the y-intercept. Sometimes it won't get it to you exactly, but you can see how it started you there at the y-axis. So you can get close, all right, and do your best, and you can somewhat see it like that. We'll talk more about your calculator a little bit later, but for now, just focus on the y equals and the graph part right here. All right, in your textbook, I encourage you to look at Appendix B.5 and B21 to also see this. All right, now I want to talk about what we call, giving this away a little bit, horizontal and vertical lines. So suppose I just give you this. Sketch the graph of x is equal to 3. I just say, that's it. That's all it is. It's a graph. Well, this doesn't look like that y is equal to mx plus b stuff. All right, so the way you'll do this is you'll pick your table. I have my x variable and my y variable. Well, generally, actually, what you would do is, all right, well, let me pick some y numbers, -2, -1, 0, 1, 2, 4.5. No matter what y variables I pick, x, it's telling me x is always 3, no matter what. Doesn't matter, okay? So when I go to plot this, these ordered pairs, like 3, -2, 3, 1, 3, 0, 3, 1, 3, 2, and 3, 3, this looks just like a vertical line. All right, so whenever you see a graph of x is equal to 3, it's just a vertical line. And that vertical line goes through the value x is equal to 3. So you go to x is equal to 3, vertical line straight up through it. Suppose I give you this, all right? The graph says sketch the graph of y is equal to -5. Well, no matter what x values I pick, -2, -1, 0, 1, 2, 3.5, it's saying, well, no, hey, no matter what x is, y is always equal to -5. So when I go to plot these points, I get this. Well, here's -2, -5, -1, -5, 0, -5, and so on. And this looks like a horizontal line. And how you plotted that horizontal line? Well, it was telling you y is equal to -5, which is down here, and then you shoot a horizontal line right through that like so. All right, so going over this. If a and b are constants, then an equation that can be put into the form of just x is equal to a has a vertical line as its graph. And that vertical line goes through whatever that value is for a right here. So if it was like 4, all right, you would go to 4 for x and then vertical line right through. All right, an equation that can be put in the form y is equal to b, excuse me, has a horizontal line as its graph. So suppose b was like 7, you would go to, or the equation was y is equal to 7. You'd go to 7 up here and then put a horizontal line right through it like that. All right, so if an equation could be put into this form, y is equal to mx plus b, or x is equal to a, all right, this right here actually is if m is equal to 0, then you just do get that y is equal to b. All right, so this is where m, a, and b are constant. Then the graph of this equation is always a line. And we're going to call this equation a linear equation in 2 variables. Right? We say 2 variables because our variables are both x